In this video, we will understand how do we evaluate definite integrals. We are taking two examples to illustrate. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top with excellent foundation. They're getting admission to the best universities, even with scholarships. Let me now explain how do we evaluate definite integrals in general, and then we'll take up these two examples. So, if we write an integral from a to b, this is a closed interval where we are integrating a function f of x with respect to x. The function should be continuous in the interval a to b. Do you understand? So it is continuous function being integrated within that interval. And the value will be f, the value of the integrand at b minus the value at a, right? So that is what it really means. And this normally we are going to write in this particular form f of x with a limit from a to b. You get the idea. So, so the integral will be a function f of x. We are going to evaluate the values of the function at b and then take away the value of the function at a. That is what it means, correct? Now, when we use power rule, let me write down now the power rule. So, if the function is of the form k times x to the power of n, right? And limits being from a to b, integration with respect to x will be k times, since k is a constant, x to the power of n plus 1 over n plus 1, and this is from a to b. Makes sense? So x is the variable, right? So you could also rewrite this as k over n plus 1, right? Simplify as much as you can, and then x to the power of n plus 1 from a to b. Makes sense? Now, if it is a polynomial and there are more than one term or any other function with more than one term continuous within the given closed interval, then you can add them up, right? So that is the basic concept. So I hope it is absolutely clear. So now let's begin with finding the value of the integral. So the first one, we need to integrate from minus 1 to 2. The function is 2x cubed plus 4x minus 1 dx. So this integral is basically equal to 2 times x to the power of 3 plus 1, which is 4, divided by 4, right? Plus 4 times x, 1 plus 1 is 2, x squared by 2, minus 1 times x. Divided by 1, we'll write only x, right? Now this is from the closed interval minus 1 to 2. Remember, this is a polynomial. It is going to be continuous, and therefore we can apply this rule. Now, it's better to simplify this before we substitute 2 and minus 1 as the values. So we get a term which is half x to the power of 4 plus 2x squared minus x within minus 1 to 2. Okay? So we'll now put 2, find the value of the first function, add 2, and then the value of this particular function at -1 and find the difference. So this will be half x to the power of 4, x is 2, 2 to the power of 4 plus 2, 2 square minus 2, right? So this is the first value. Take away half. Now we'll write -1 to the power of 4 plus 2 minus 1 square minus minus 1, right? Correct. Now half 2 to the power of 4, which is 16, and half of 16 is 8. Plus 4 times 2, which is 8, minus 2. From here we have to take away half. Minus 1 square is also positive, plus 2 plus 1. Perfect. So 8 and 8, 16 minus 2 is 14. Take away 3.5, right? And taking away 3.5 gives us 10.5 as the value of this integrand. Is that clear to you? Perfect. Now, same concept will be applied to the next example. So it is from 1 to 9, square root of x, 1 over square root of x. They are continuous within this interval. Discontinuity here is x less than or equal to 0, right? Now, you can rewrite this expression as integral 1 to 9, x to the power of half, we'll add 1 to half, right? Plus x to the power of minus half dx. Make sense? So now, let's write down the value from 1 to 9, or we'll just give the limit. So let me save some space here. X to the power of half plus 1 will give us 3 by 2 over 3 by 2. And here we have plus x to the power minus 1 plus 1 will be half, right? Divide by x to the power of half. And this is from 1 to 9. Correct? Now this can be written as, it's important to simplify, 2 over 3 x to the power of 3 by 2 plus, or here it is only half, not x to the power of half. So it is plus 2 times x to the power of half, which is square root from 1 to 9. Now we can substitute the values. Let me change the ink. We get 2 by 3. X is 9 to the power of 3 by 2 plus 2 times 9 to the power of half, right? So that is first part, minus, let's put 1 now, 2 by 3, 1 to the power of 3 by 2 plus 2 times 1 to the power of half. Correct. So that gives us 2 by 3. 9 square root is 3 and 3 cube is 27. Plus 2 times 9 square root is 3. And here we get minus 2 by 3 because 1 square root and 1 3 by 2 is 1. So 2 by 3 plus 2. Correct. So now we get, let me change ink back. So 2 by 3 of 27 means 9 times 2, 18, plus 6 minus 2 by 3 plus 2 means minus 3 times 2 is 6, 6 plus 2, 8, 8 over 3. So we can add this up, 24 minus 8 over 3, which is 3 times 4, 12, 2, 1, 72 minus 8 over 3, which is 64 over 3. You see that? So that is how we can evaluate the value of this definite integral. So remember, integration gives you a function, but when you have a boundary conditions given to find the definite integral, you can find the value, which represents the area under the curve. I hope it makes sense. Follow our playlist to understand more with so many examples. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.